Hi everyone. Today we are going to solve a problem from Fortnight 15 of SuMON program. This is from level 4 of SuMON program. And let's consider a cuboid with base face ABCD and top face EFGH. And the length measurements are given. Breadth and height are also given. Now, let X be the midpoint of side AB and Y be a point on the segment BF such that it divides the segment in the ratio 3:1. So these are how the points X and Y are defined. Now consider the plane formed by the points H, X and Y. We know 3 points define a plane, and this is the plane defined by the triangle thus formed. Now, this plane will intersect the segment AD and it will divide the segment AD in some ratio. We are going to find that. Some of our students actually attempted them, and few solutions are really beautiful. They approached it using coordinate geometry. But it was the algebraic part of the possible solutions. But now we are going to take an intriguing approach towards it. And let's solve it through elementary geometries. And let's use only similar triangles. Let's get started. So here is the problem that we are going to solve today. This is just a formal statement of the problem. So it is just like as we had discussed, the measurements of length, breadth and heights are given. So here we go with the bottom surface ABCD and the top face EFGH. And as you can see, the points X is the midpoint of AB and Y the point that divides BF in the ratio 3:1 are marked clearly. Now, let's take the plane formed by the triangle H, X, Y. Now, this is the plane that contains this triangle. That's it. And we know a plane shall extend indefinitely in all possible directions, right? So this is not only confined to this triangle. Let's make it broader and extend it. So if you do that, it will just go on like this to intersect the segment AD at some point. Let's call it as Z. Let's call it as Z. And we are asked to find AZ by ZD. That is the ratio in which Z divides the segment. So first, let's learn something. So if you consider a line, it either intersects this plane exactly once or it intersects at no point, in which case it is parallel to the plane, or the third case, it is intersecting at infinitely many points. This happens when the line coincides with the plane or the line lies on the plane. So there are only these three possible cases. And we know that AD line is not parallel to the face or the plane. It must intersect the plane, either at infinitely many points or at exactly one point. Now it's not infinitely many points because point A will not be on the plane. And the reason is that point X is already on the plane HYX. And hence, either the plane contains the entire line AB or only the point X. Now, clearly the plane is at some angle with the line AB. So it's not going to contain the entire line. So point A will lie outside, and thereby point D will lie outside. So this is evident from visual conclusions. So let's get deeper into this claim. So consider the line HX. Let's consider the line HX. Clearly, the line HX lies on the plane because 2 points lie on the plane. So since the entire line HX is now on the plane, the intersection of this line HX with the plane defined by BCGF will also lie on this plane. Let's call this plane as delta. Let's call the plane HXY as delta. This will be convenient for us to mention in the solution. So the point of intersection of HX with the plane BCGF shall also lie on the plane delta. And now the intersection will happen to be the reflection of point G about the point B. So when G is reflected with respect to B, it defines the intersection of the line HX with the plane BCGF. The reason being that X is the midpoint. Notice that X is the midpoint. Now, since X is the midpoint, it takes the point H, which can be visualized as into the plane, to a point out of the plane at the same distance, conforming to the symmetry of the diagram. So thereby, it will go out of the plane by the breadth of this cuboid, and it will go down to the face ABCD by the height of the cuboid, because capital H is located inside the plane at a breadth of 4 and at a height of 4 with point X. Now the opposite of that will happen when you reflect it, right? And it explains the behavior of the reflection. So let's call that point to be here, and that clearly would form a face that is symmetrical with the face ADHE. But it coincides with the plane BCGF, and the dimensions of this rectangle will also be 4 and 4, because we know that height of this cuboid is 4 and length of this cuboid is 6 and the breadth of this cuboid is also 4. So hence, considering a view from the side explains a better perspective for this diagram. So let's move to the side view. Here is the side view, having the face BCGF of the cuboid, and that is this face. As you can see, BCGF is this face. So I'm just replicating that in the diagram below. And followed by we have MKB and some unnamed vertex. Let's name it as some point T. So MKBT. is this one, which is obtained as a result of symmetry by the reflection of the face ADHE with the point X. And we will land up here. Now, we know that the point M belongs to the plane delta. And as per the question, Y belongs to delta, which is on the side BF. And that divides the segment BF in the ratio 3:1. And segment BF is of length 4. And hence BY is 3 and YF is 1. So this makes the coherent construction of our subsequent solution. So now the entire line MY will lie on the plane delta because 2 points M and Y lie on, already are proved to be on the plane delta. So hence the intersection of MY with the side BC of the cuboid, the extended side CB of the cuboid, intersect at a point N shall also lie on the plane delta. So let's find few properties of the point N. I will explain why we are concerned about the point N later. So now let's just find the position of point N. So now observe the similar triangles YNB and MKN. They are similar because the line MK is parallel to the line BY. And hence their alternate interior angles are equal. And 90 and 90. And hence the other two angles are also equal. So hence they form a pair of similar triangles. So let's write out the similarity. We reduce the triangle MKN is similar to triangle YBN. Thus, MK by YB equals Kn by Bn. So we get that Bn upon Kn equal to Yb by Mk, which is 3 by 4. Hence, N divides the segment Bk in the ratio of 3:4, where we know Bk is 4, because that corresponds to the reflection of breadth of the point H with respect to the point X. I hope you would still remember that. So this was some imaginary triangle obtained after reflection. So it should coincide with the phase on which H was lying on. So 3:4 is the ratio and length is 4. Hence Bn equal to 3 by 7th of the total length KB, which is 3 by 7 times 4, making it 12 upon 7. So now we have figured out Bn. But how is the point N actually going to help us? So we know N belong to delta as it lies on the line MY. Now let's take the top view again. So here we are back with the cuboid again. And let's mark the actual location of point M. Point N is the point on extended side CB such that it lies on the plane delta on our required plane HXY. So that is HXY shall pass through this point N or intersect CB at this point N. So that's the idea behind realizing the point N, because when you consider 2 points in delta defined by those 2 points shall entirely lie on the plane. So hence, the line nx entirely lies on the plane delta as shown. So now, this is the point z that we are interested in. But do notice that x is the midpoint. So ax is equal to bx. And we have angle DAX 90, which is equal to XBN 90, and vertically opposite angles. Thus, by ASA congruence, triangle AXZ is congruent to triangle BXN. Thus, we get AZ equal to BN. Now, BN is 12 by 7. So AZ is also 12 by 7. And DZ is basically 4 minus AZ because 4 is the total length. So this is 4 minus 12 by 7, making it 28 minus 12 by 7, which is 16 upon 7. So hence the ratio AZ by DZ would just be 12 by 16, making it 3 by 4. So the point Z divides the segment AD in the ratio 3:4. So we just use the fact that if 2 points belong to the plane, then the entire line defined by those 2 points lie on the plane. And if exactly 1 point lies on the plane and one other point do not lie on the plane, then the line shall intersect the plane only at 1 point. And it could be no point of intersections between a line and plane when it becomes parallel. So we just used that idea and slowly we projected the points on the face BCGF, then to the line BC. And then we concluded the point Z to be the symmetric point of point N because X is the midpoint. So share your ideas and solutions in the comments. And I hope you enjoyed the video. Meet you all in the next video. Happy learning. Bye.